Okay class, Assalamualaikum and good day. So today we want to see what is scalar triple product. Okay, so before this we have learned about the dot product and also the cross product. Okay, so the scalar triple product is actually the combination of dot product and also a cross product. Okay, we have a scalar triple product of three vectors. So kita ada vector A, vector B dan vector C, and is defined as vector A dot vector B cross product with vector C. Okay, so ini kita panggil sebagai scalar triple product, where in this scalar triple product we have a dot product and also the cross product. Okay, so let's say we have the scalar the vector A dot with the vector B cross with vector C. Okay, so we call it this one as a scalar triple product. It also can be vector B dot product with the vector A cross vector C, and it also can be the vector C cross dot product with the vector A cross with the vector B. Okay, but this one is called as a scalar triple product, where it's combine both dot product and also a scalar product. Okay, a cross product. So we want to see a properties of scalar triple product. If we have the vector A as A1I plus A2J plus A3K, where this one is called as a component vector of vector A. And then we also have the vector B as B1I plus B2J plus B3K. So B1I, B2J, B3K ni adalah vector component untuk vector B. And we have vector C equal to C1I plus C2J plus C3K, where C1I, C2J, C3K adalah vector component untuk vector C. So if we have the vector A dot with vector B cross vector C, we can write our vector as in this form. Okay, awak tengok. This one is our vector A, A1I plus A2J plus A3K dot with B cross C. So B cross C kita tulis dalam bentuk macam ni. Macam determinant ni. Okay, so macam mana kita nak selesaikan the B cross C first, because B cross C is in the bracket, so we need to settle B cross C. So kalau B cross C, okay, kita cancel this one first. So this one is for I. Then we have B2 multiplied by C3, and this one is B3 multiplied by C2. Okay, so then if we cross the first row and the second column here, so this one is for J. Okay, don't forget that we have minus sign here because it's the second one. This one is plus minus plus. Okay, the second one, so it will be minus J, and the determinant of B1, C1, B3 and C3. Okay, and if we cross product, if we cross the first row and the third column here, okay, so we cross the first row and the third column here, therefore this one is for K, okay, and the sign is plus. Okay, then you have B1, C1, B2, C2, B1, C1, B2, C2. So this one is how we find the cross product. We have learned it before. Okay, so when you find the cross product, okay, then when you want to do a dot product, okay, let's say before this we have, for example, a vector A equal to 2I plus 3J minus 5K, and vector Z, for example, equal to 4I minus 2J plus K, for example. So how do you do a dot product between A and Z? You will take the coefficient of I multiply with the coefficient of I for Z. Okay, then you will plus with the coefficient of J here, multiply with the coefficient of the J for Z here. Okay, and you plus with the coefficient of K, multiply with the coefficient of K for the second vector here. So this one is how we do a dot product. Therefore, when we want to do a dot product between the vector A and also the B cross C, okay, what you need to do is the coefficient of I will multiply with the coefficient of I here. Okay, so you will have A1, and in the bracket or in the determinant is B2, B3, C2, C3. This one is for I. Then we plus with determinant, the coefficient of this one, J, plus with the coefficient of J. And don't forget that you have plus and minus here. It will give you minus. Okay, then you have A2 multiplied by this one. Okay, plus with the coefficient of k multiply with the coefficient of k here, because we are now doing a dot product. Okay, so we will have a plus A3 and a whole thing in the bracket here. Okay, so if you can see, okay, this one is actually the determinant of matrix A1, A2, A3, B1, B2, B3, C1, C2, C3. Because if we want to find the determinant of this matrix, what you do, you will cross the first row and the first column. What you will get here is for the A1, and A1 is plus, so A1. Then you multiply with determinant of the remaining item here. So you have B2, B3, C2, C3. Okay, then you will continue to eliminate the first row and the second column. Okay, the first row and the second column. Therefore, this one is for A2. Don't forget that the sign is minus, so you have minus A2, and determinant of the rest element here, B1, C1, B3, C3. Okay, and the last one, when you eliminate the first row and the third column, okay, when you eliminate the first row and the third column here, so this one is for A3, the sign is plus, and the remaining item here is B1, B2, C1, C2. So if you compare this one and this one, okay, this one is the same thing. Means that this one, okay, this one, when we do a dot product of A and B cross C, we actually can write it as a determinant of A, B, and C, but you need to be careful with the row. Okay, with the row. This one will be the vector A dot vector B cross vector C. This is the order you need to follow. Okay, if you have vector B dot vector A cross vector C, you cannot write it as this one anymore. You cannot. Okay, you need to follow the order. The first one is vector B cross vector A, vector B dot vector A cross vector C. Therefore, the first row will be the element for vector B, which is B1, B2, and B3. The second row will be the element of vector A, which is A1, A2, and A3. And the third row will be the element of vector C, which is C1, C2, and C3. So this is how we write the determinants of a vector when we have the triple scalar product. That one is the first property. Let's see the second property here. By property of determinant, which state that interchange of two rows of determinant changes its sign. So we have, okay, we have seen before the dot product of A dot B cross C can be write in term of this determinant. Okay, follow the order. This one is A dot B cross C. Okay, need to follow the order. If you change two row by using the property of determinant, if you change two row, A1, you change with B1, okay, it will give you the negative sign here. Okay, so now you see the row have been changed from B1 from the second row to first row, and A1 from the first row to second row. So you have negative in front here. Okay, because by properties of determinant, interchange the row or column will give you the negative value. Okay, now you can change A and C, that will give you another negative value. So negative times with negative, it will be positive. But now your A will go to row number 3, and your C from row number 3 will go to row number 2. So you have here B1, C1, and A1. Okay, so this one is B dot C cross A. This one is how you read the determinant matrix. Okay, so what we can say is this matrix is equal to this one. Okay, means that the A dot B cross C is actually equal to B dot C cross A. Okay, another example here. Let me see. Okay, another example here. Let's say we have the dot product here, the scalar triple product here, A dot B multiplied by C. So we already seen that this one can be written in the form of this matrix, okay, where this one is A dot B cross C, okay, according to the order. So if you change the position of C1 and B1, okay, sorry, if you change the position of C1 and any row, you can change the position of any row. Let's say you change the position of C dengan A. Okay, so you tengok C naik ke row nombor 1, so A daripada row nombor 1 turun row nombor 3. So bila kita interchange dua baris, kita akan dapat negative 1 dekat depan. Sign dia akan jadi negative. Okay, then you can change this row pergi this row, so dia akan jadi row number 2, daripada row number 3 jadi row number 2, dan daripada row number 2 jadi row number 3. So bila kita tukar interchange row, we will get another negative 1 here. So negative and negative is positive. So what we can see from here is A dot B cross C, okay, equal to C dot A cross B. So this one is the one that you can find on your own. Okay, awak boleh cari on your own. Okay, so what we can say that A dot B cross C is actually equal to B dot C cross A, or equal to C dot A cross B. Mana-mana pun sama. Okay, nilai dia adalah sama. So kalau awak nak selamat, awak boleh guna property ni untuk tunjukkan bahawa hubungan this one is equal to this relationship. Okay, so that one is the second property. Now let's see the third property. By property of determinant, we state that if any two row or any two column of determinant are identical, then the value of determinant is 0. Okay, menggunakan properties of determinant yang awak belajar sebelum ni, kalau dalam vektor atau dalam matrix tu ada dua row ataupun dua column yang identical, sama, maksudnya determinant dia akan equal to 0. So bila kita ada A dot with A cross B, macam mana kita tulis this one? Katakanlah elemen A adalah A1, A2, A3. Okay, so kita akan ada A1, A2, A3 dekat first row. Then dekat second row pun kita ada A1, A2, A3. And dekat third row kita ada B1, B2 and B3. So now if you can see in this matrix, we have two identical row. Ada dua row yang sama. Therefore, kita conclude dia punya determinant is equal to 0. Okay. Sama juga kalau awak mempunyai kolom yang sama. So, kita conclude that kolom itu, kita conclude that determinant untuk matrix itu adalah sama dengan kosong. Okay. So, itu adalah property number 3. Now, let's see the property number 4. Okay, let's see the property number 4 here. If you have, okay, by distributive law of scalar and dot product, if you have the vector A tambah dengan vector D, okay, dot product dengan vector B cross C. So, apa yang boleh buat? Awak ambil satu ni, dot dengan this one. Okay, so dia akan jadi A dot dengan B cross C plus D dot dengan B cross C. Okay, macam seolah-olah kita bagi setiap satu ni B cross C. Okay, kita bagi B cross C yang pertama untuk A, dan kita letak B cross C yang kedua untuk D. Okay, so ini adalah distributive law. This one is property number 4.